And here you can see the method by which we're taking the inverted reading. So uh, the requirement is you want to find the reduced level of the sunshade level. So you have to find the reduced level at this point. We cannot place the reduced level, or we can take the reduced level by placing the leveling stuff on the ground. So in that case, we'll be placing the leveling stuff inverted on the sunshade, and we will take the readings directly. Okay, so we'll be keeping the leveling stuff inverted and we'll take the readings directly. But in the value entry, so in the table where you list the values, you're supposed to write it as negative value. So the reason is that, like, you're having the dumbbell level here, and when you see directly the point, it will be the, like, the level, and you are supposed to add this much height from the top to this much level to get the reduced level of the sunshade. So in the entry values, you're supposed to write it as the negative value. And hope it's audible to you. Okay, thank you.
Yes, sir.
So that's about taking the readings in inverted way. The next important one is the profile leveling. So, say introduction to the profile leveling. When we do the chain surveying, we assume that the ground is uh, like it is flattened. That means there is no undulations on the ground. But that assumption is not always true. There will be some up and downs in the ground itself, which will affect the values, like the areas. So in some cases, we are supposed to find the profile of the ground, both in the lengthwise as well as in the sideways. So a quick idea of what is profile leveling. So we have a long chain here. So to get the, suppose we have, okay, suppose we want to measure a plot like this, a big plot like this, you have to uh, place the chain along the diagonal or the longest diagonal, and then you will be measuring uh, along the length as well as both the sides, also the perpendicular to the straight line. So here you will be having a 30-meter chain or 20-meter chain, and you'll be placing the chain along the length, and at definite chain edges, suppose for the zero chain edges, based on the width of the plot. So here we are making two measurements at the 2-meter distant, equidistant from the center, and also 4 meter from the center. So towards left 2 meter and 4 meter, and towards right 2 meter and 4 meter. And after the zero chainage, we are also placing the uh, we are taking the readings again on the 5 meter chainage. Suppose it is a total like 30-meter long plot, we can take the intervals as you wish. As the intervals are very closer, you'll be getting accurate dimensions. So it depends on how exactly or how accurately you want to get the profile leveling. So in the experiment or the video recorded by us, we did a chainage of 5 meter. That means at every 5 meter points, we made a chainage. So basically, you will be keeping your dumbbell level at the zero chainage, and you will be keeping the leveling staff at 2 meter distance, 4 meter on the right as well as on the left side, 2 meter and 4 meter. Then you can either shift the dumbbell level to the 5 meter, or if the points are visible clearly, you can take the measurements from here itself. So from the zero chain age dumbbell level placement, you can take the readings to the 5 meter center point, and towards the both sides, 2 meter and 4 meter, both ways. So I'll be getting the profiles. So a quick video of the same. So this explains from the starting how they are unfolding the chain as well as placing the arrows. So this chain is 30-meter long, and you can see a tali here. Okay, so okay, this shows how to unfold the chain. We're supposed to keep the handle of the chain on the left hand side, and to throw the chain. So this is the way by which you're unfolding the chain. And the leader moves with the chain to stretch it to 30 meter. So by this way, we are initially placing the chain and getting ready for profile leveling. It's 30-meter chain. So what I was telling that we will keep the dumbbell level at the zero chain age or the start point, and we'll take a benchmark. Suppose this blue box is the benchmark, and we are placing the dumbbell level on the zero chain age. We will first sight to the benchmark, and we will get the height of the instrument by positioning or by placing the dumbbell level at the zero chain age. We will take the IS intermediate side to the various points. Suppose like on the zero chain age at 2 meter towards left and 4 meter the intermediate sides, and also towards the right 2 meter and 4 meter. And similarly, if you want, you can change the station to the 5 meter. Otherwise, if every points are clear, you can directly take the IS to the left and right of the 5 meter chain edges, and you will be getting the reduced level of the various points. Okay, so the video shown here. So this video clearly explains the profile leveling. So this is the first benchmark point. So he by placing the leveling staff at the benchmark point, he will get the height of the instrument, and this is the first reading taken. Actually, this video or the value in this not too clear, but what is done here is that we are writing the zero chainage and 2 meter and 4 meter on the left hand side table, and also 2 and 4 on the RHS. Similarly, for the zero chainage, we are writing again for the 5 meter chainage, and we will find the reduced level of every points, like the zero chainage left 2 meter, zero chainage left 4 meter, zero chainage right 2 meter, right 4 meter, and then again 5 meter chainage left and right on equal distance of 2 meter. We'll find all the reduced level. So the first side to find the height of instrument, or the first side to the non-reduced level, is called as the back side, and the value is 0.810. I think the video is now a little bit clear. You can draw a box like this or table like this, A, B, C, three columns. I hear me? Can you hear me?
Yes, sir.
Okay. So you can draw a table like this, A, B, C. Basically, A, B, C, D, E, or you can like A, B, C, D, E, where C is the central point, and A and B are the points on the left hand side, and the D and E are the points on the right hand side. So A, B, C, D indicates the chainages and the location of the various points, and then the reduced level table will come. So you know how to take the readings. So the first reading to a known benchmark will be the backside value. It is 0.810. We assume the reduced level of the non-point or the benchmark to be 100. So in this video, what he did is that he's not placing the dumbbell level on the zero chainage. He is placing the dumbbell level at a farther point, and he has already taken the backside to know the height of instrument. Then he is citing the zero chainage center point. So the first reading, zero chainage center point. So 1.295 is the intermediate site reading, which he got by citing on the zero chainage center point. Again, repeating, it is 1.295. So you can see he has written the value in line with the center 1.295. The first value was 0.810 to get the height of instrument. So next is going to take the value at 0 chain edge 2 meter left side. So the person is moving from 0 central point to the 2 meter point left. So the value is 1.265. So previously we had 1.295. So there is some difference along the cross section. Same chainage, when he moved towards the left by 2 meter, there is a difference of 1.295 minus 1.265. 265 on 2 meter left. Again, he changes from 2 meter to the 4 meter on same chainage 0. And he is citing the 4 meter point. There is some disturbance because of that plant. So the value is 1.315. So you can now clearly see the first value, the 0 chainage 0 meter, 0 chainage 2 meter, 0 chainage 4 meter, 1.315. So along the bridge or along the cross section, there is change in the reduced level. So this is very important during survey, because normally we will assume that the ground is flat, but there is some undulations and will be very critical when we are measuring very like large areas. Then then the leveling staff is taken to the right side of the zeroth chainage, 2 meter. So the value is 1.290. So the next reading, 0 chainage 4 meter reading. 1.295 meter. So now we completed. So we placed some maybe some instrumentation at this point, and then we took a backside to get the height of the instrument from the station or from the dummy level point. We sighted initially the 0 chainage, took for 2 meter reduced level, 4 meter reduced level, then again right 2 meter and 4 meter. So we completed the cross section at the 0 chainage. Then from the same point, we can sight to the 5 meter center, 2 meter and 4 meter on the left and the right sides. Sorry. So now the process on 0 chainage is over. Now he is walking along the chain length, 0 to 5 meter, center portion. So the reading is 1.285. Then as I told you, 5 meter, 2 meter left side. So the value is 1.32 meter. So 1.240 is the reading on the 4 meter on left side of 5 meter chainage. Now he is moving towards the right 2 and 4. One 1.325. So 1.295 is the last reading. So we are supposed for a like a for 30-meter long chain or that much long aid measurement, we are supposed to find the cross sectional values at 0, 5, 10, 15 based on choices. But in this video, he stopped or he took only for the 0 and 5 meter, and he is closing the session. So as per the chain surveying procedure, the last reading should be a foresight. So we are entering the 5 meter chainage right side 4th meter value as the foresight only because we are as we're stopping the readings for the day. One 1.295 is the last reading foresight. So this is how we will take the readings. And this Excel sheet I just shown like a model or how it's like look like. So I told you there is a undulations along the it can be around the length also, because when you sight from the dumbbell level to 0 chainage as well as the 5 meter chainage, there will be level difference between the 0 and 5, and also towards the cross section there will be changes in the cross section also. So the ground won't be a flat, and there will be some reduced level difference within the area. So after the taking the or first backside, then IS, and then the foresight, we can find the reduced level in the next column. Okay, if you writing the same, we can find the we can write reduced level as the next column and write all the reduced level point. So then after that, you can plot the cross section like this. You can plot for 0 chainage, so the variation of the cross section. Like 4 meter, I have written for the 5 meter. Like for 5 meter chainage, at 4 meter, the value reduced level or the reading is 1.240, and then the 2 meter, what's the value and all. Then this type of work is mainly done for finding the volume of soil there has to be excavated. Suppose you're having a very undulating ground. It is very maybe sloping ground. You want to level the area. So by measuring the undulations on the surface, we can have a calculation of how much the soil or the earth has to be removed to make the ground flat. Okay, the values for this one I will give later. I will share by Excel sheet or by as a question to find the area. So for every see, for this one you have 0 meter and 5 meter chain. So to find the total area, before that, hope my screen is visible to you. Is it visible to you? Screen?
Yes, sir.
Okay, thank you. So this shows
Leveling with inverted level.
way of
In
doing
this
the
video,
inverted
let us
leveling.
see how to do differential leveling using inverted staff. A building which is in the stage of construction is selected to
The YouTube audio is clear to you?
Yes, sir.
Okay, thank you.
do the experiment. Two leveling staffs are placed in stations A and B respectively in front of the building area. An instrument is fixed at station O between stations A and B. From instrument position, station A is sighted and the reading is noted as backside reading in field
First
book.
reading is the backside
The reduced
1.623.
level of benchmark is taken as 100. From the same instrument position, station B is sighted and the reading is noted as foresight reading since the instrument position is to be changed. Another staff is
Very
placed
important. The reading is taken or written in the foresight because it's going to shift the dumbbell level position, going to shift the station. Otherwise, it should come in the IS.
in the building in inverted position, that is, the base of the leveling staff touching the ceiling of the building.
Okay, this is the one I was
point
telling
is
about the inverted reading. We want to find the reduced level at this point, at the sunshade level. So the person has to keep the leveling staff in inverted position.
noted as station C. Instrument position is changed to station O1.
Okay, now
From
the
O1
position
station-
is station 1 is changed to station 2, and he's supposed to backside the second point to get the like the new height of instrument.
Side station B and note the reading as backside. Then side station C and note the reading as foresight with a negative sign since it is inverted leveling.
This is the main point. When you're taking the inverted reading, you are supposed to write the value as negative. Then only you will count. It will be like when you deduct from this value, some minus will come to plus. So we will add the height of instrument plus 2.420 to get the reduced level of the sunshade. Is it clear for you? Is it okay for you?
Yes,
Anybody
sir.
ready? Okay. We'll keep doing.
Now the staff is placed at station D in inverted position and instrument is changed to position O2. From O2, station C is sighted and noted as
So as again he is changing the station points. This is third station point. He is again backsighting the point that in inverter point.
backside with negative sign.
Again value is minus 0.951.
Then station D is sighted and noted as foresight reading. Now the staff is placed in station E in normal position and the instrument is shifted to station O3. From O3, station D is sighted and the reading is noted as backside with negative sign. Again, from station O3, station E is sighted and noted as foresight with positive sign since it is placed normally on the ground. Reduced level calculation. The RL of benchmark is taken as RL of station A. The height of the instrument is calculated by adding the RL of benchmark and the backside of station A. RL of station B is calculated by subtracting the foresight from previous HI value. Then HI value for station B is calculated by adding the RL and backside of station B. RL of station C is calculated by subtracting foresight from previous HI value. Again, HI value is calculated by adding the RL and backside of station C. Similarly, RL value of station D is calculated. HI value of D is also calculated by adding RL and backside of station D. Finally, the RL of station E is calculated by subtracting its foresight value from previous HI value. For arithmetic check,
So then the routine checks
summation
follows. Then adding one more thing. Yeah, this is also one interesting video regarding the contour. So the contouring is also the same way or the similar way for the profiling. Contouring is all about getting the relative level differences of various points in an area or a ground. So as we told, we are placing the dummy level at any point so that the entire ground to profile is visible, and the first reading is the backside. We are getting the height of the instrument.
as reading in field book. Divide the area into number of squares with side 10 meter, which the contour is to be drawn. Station 1 reading is taken.
This is a different way or different type of contouring that I explained in the previous case. So this here in this case, the surveyor wants to get the profile of this square area. So he divided the total square area into like small squares and different points. For in this one there is some 30 points, and in these 30 points he will be measuring the reduced level at various points, and by measuring the reduced level at the 30 points he will get an idea regarding the relative level difference between each and every point.
Noted as intermediate site.
So as he is able to see all the 30 points from the single station, he can enter all the values in the IS, intermediate site. So, and for closing the contouring, the last value should be in the foresight. So I'm skipping. So he's writing all the values,
89.
and the
Level
last
of
value
station
as
1
you're closing the contouring should be in the foresight.
is calculated by subtracting its intermediate site from
Then
height
the
of the
regular
instrument
thing of
value.
finding the
The
height of
reduced
instrument
levels
and
of the
reduced
other
level.
stations is also
You know already.
calculated by subtracting intermediate 2.825 minus
And the
RL of
regular arithmetic checks
station is checked and
of
the
sigma
obtained
PS
RL
minus
values
sigma
are
foresight is
correct.
equal to last RL minus
The
first
RL
RL.
values obtained are noted in a horizontal distance between station 1 and 80-meter contour is equal to
That's the work. So, and from I want to ask a question to you. Suppose you got the various levels of this point. Suppose this point is some on the level, and this 0.5 meter, this 1 meter, or different values. How to find the total volume of this plot, or the volume of earth to be excavated? Any idea how to find the quantity in volume? Suppose what I was telling is that um, suppose for this one the value is say uh, 1 meter, 1 meter. Then we have here okay, 2 meter. Let the total not from the 2 meter can be 1.5, and okay. Suppose the chainage 0 as well as the chainage at 5 meter are same level. Suppose both are at 1 meter from the ground level, both at 1 meter, and the left side is at 1.5. So to make a flat down, how much earth has to be excavated? Suppose treating the 1 meter as the flat level. How to find that? Any idea? Hope my question is clear to you. Uh, I want to level this total ground, and the level should be at the height of 1 meter. So along the length here is fine, and here it is 1.5 and 1.5. So how much earth has to be excavated from this area to get a level surface in 3D way? How to do that? Any idea? Uh, just a picturization of this one. This is the 0 meter, and this is the 5 meter. So when I go towards the left side, this is at this is at like 0.5 meter. More earth is here on height way 0.5 meter here. So how much I want to excavate from this area to get a level like this? Is it clear? Question is clear to you? No responses, Felix?
ഹലോ സർ.
Yeah.
സർ ഞങ്ങൾക്ക് യൂട്യൂബിന്റെ വിൻഡോയാണ് കാണുന്നത്.
Oh, അതാണ് okay, fine. Oh, sorry. I was showing something in the Excel. Now it's okay. We're saying the Excel
Yes, sir.
sheet. Okay, fine. So what I was telling is that there is 0 chainage, 5 meter chainage. Assume that the 0 meter chainage point, center point, as well as the 5 meter chainage point are at same level. Towards the left, on both 0 meter and 5 meter, the height is 1.5. Here 1.5 and here 1.5. So to keep a level at 1 meter point, how much earth I want to excavate? So just same figure I have drawn here to make it more clear. So this is the 0 meter, clear? 0 meter. This is the 5 meter. So I want to excavate this much earth to get a flat surface. So how to find the volume of earth here? So how much volume of earth I want to remove to get a flat surface for this 2 meter width? Response from you?
സർ ഏരിയ ഇൻറ്റു വോളിയം.
Yeah, same thing. Not area into volume, area into length. So what has to do is I told you this is 1 meter, this is 1.5 meter. So difference between 1 and 1.5. So 0.5 is the base, right, of this right angle triangle. Base value is 0.5. So half BH will give you the area of
ട്രയാങ്കിൾ.
this cross section by assuming it is straight. Though this cross section area into the total length into 5 meter will give you the volume of earth you want to excavate so that it can make a flat surface at 1 meter level. Clear for you?
യെസ് സർ.
So by this simple process or by this method, we can find for a larger area also how much earth has to be excavated or even filled. So suppose I want to so this was a case of removing the earth. Suppose I want to fill or I want to make a level surface 1.5 meter. So you want to you want to fill the earth, right? Hello.
സർ കേൾക്കാം.
Okay, so the first question I discussed was regarding the like excavation to make the 1 meter level. Suppose in another case I want to make a level at 1.5 meter height, then I want to fill the earth. So in that case also you can find the volume of earth fill required so that you can keep the level at 1.5 meter. So this by this simple process or by this technique you can find the requirement or the volume of soil you has to excavate or fill to make a flat surface. Clear for you?
യെസ് സർ.
Okay. So that's all about the inverted staff reading as well as the profile leveling. Okay.
സാർ ഞങ്ങൾക്ക് 2:45 ക്ലാസ് ഉണ്ടാവും.
ഞാൻ മൈൻഡ് അപ്പ് ചെയ്യാണ്. ദീപക് is online.
ഓൺലൈനാണ്, ക്ലാസ് എടുക്കാൻ പറ്റില്ല.
ഫൈൻ ദീപക്, ഇത് മതിയില്ലേ ഇത്രയും? നമുക്ക് അതിന് ഷെയർ ചെയ്യാം ആ ക്വസ്റ്റ്യൻ പ്രോപ്പർ ആയിട്ട്. ഓക്കെ,
കൊടുത്തില്ലേ?
റീഡിങ്സ് ഞാൻ 5 മീറ്ററിന് വരെ എത്തിയിട്ടുള്ളൂ. അതായത് എടുത്തതേ കൊടുത്തിട്ടുള്ളൂ. വേണമെങ്കിൽ 30 മീറ്ററിന്റെ വാല്യൂ ചെയ്ത് കൊടുക്കാം. ഓക്കെ
സർ ടേബിളും കൂടെ ഒന്ന് ഷെയർ ചെയ്യോ? അത് കണ്ടില്ലായിരുന്നു.
ടേബിൾ ഞാൻ ഷെയർ ചെയ്യാം തീർച്ചയായിട്ടും.